Hello, you are welcome once again to this lesson. In this lesson, we are going to learn about one of the most important protocols that has contributed to the success of communication in computer networks. This protocol is called the TCP/IP. After this lesson, you will be able to understand what a protocol is, what TCP/IP means, the purpose of TCP/IP, the TCP/IP models and their various roles, and how different is the TCP/IP model from the OSI model. Before we delve in, let's take a quick recap on the previous lesson. In the previous lesson, we studied about bits. We spoke about the meaning of bits and its significance in digital communication. We also saw the reasons why computers communicate using bits. We spoke briefly about character sets and how computers represent characters and graphical symbols. Again, we learned how binary digits are converted into decimal digits and vice versa. Lastly, in relation to IP addressing, we learned about the lowest possible bit and the highest possible bits we can use in IP addressing. Beginning today's lesson, let's see what a protocol is. Protocols, in simple terms, are a set of rules agreed upon that systems follow to ensure effective communication. Before computers in a network can communicate, they have to know ahead of time. 1. How they are expected to communicate. 2. How the communication should start. 3. Whose turn is it to communicate? 4. How does each computer know its messages were transmitted correctly? 5. And how do they end the communication? All these are done through protocols, and this is where TCP/IP comes in. TCP and IP are two separate computer network protocols. TCP means Transmission Control Protocol, and IP means Internet Protocol. IP is the part that obtains the address to which data is sent, and TCP is responsible for safe data delivery once that IP address has been found. TCP and IP are often used together, therefore written as this, TCP/IP. Now, to delve deeper into the origin of TCP/IP, let's see some brief history of these protocols. TCP/IP was created by the U.S. Department of Defense. This was to ensure integrity of data as well as to maintain communications in the event of war. This was created in the 1970s for use in ARPANET. ARPANET was a wide area network that preceded the Internet. ARPA stands for Advanced Research Projects Agency. It was the research unit of the U.S. Department of Defense. TCP/IP was originally designed for the Unix operating system. Due to its effectiveness in computer networks, it has been built into almost all operating systems of today. Now, let's see what TCP/IP does exactly and how it works. TCP/IP divides the different communications tasks into layers. Each layer has a different function. Data goes through 4 individual layers before it is received on the other end. At the receiving end, TCP/IP then goes through these layers in the reverse order to reassemble the data and to present it to the user. These layers include 1. Network access or physical layer. 2. Network or internet layer. 3. Transport layer. 4. Application layer. The purpose of these layers is to ensure standards and not allow vendors of network devices do their own things. Now, as we learned earlier in the OSI model lesson, the functions of the OSI model layers are similar to these and still applies here. The layer 1, which is the network access layer, is also called the link layer, network interface layer, or the physical layer. This layer involves the physical parts of sending and receiving bits, using the Ethernet cable, Wi-Fi, fiber optics cable, network interface card, and so on. In a nutshell, this layer gives other devices access to connect to the network. The network layer, sometimes called the Intranet layer, controls the movement of packets throughout the network. It involves the work of some useful protocols such as the Address Resolution Protocol, Internet Protocol, and Internet Control Messaging Protocols. We will talk more about these protocols as we progress in this course, but for a short moment, this illustration shows how an ARP works. In this local area network, if this host intends to send this packet to this host, the network layer attaches a source IP address and a destination IP address. Now, an ARP will send a broadcast message asking for the MAC address of the destination host. The host with this IP address will then respond with its MAC address. Then, the packet is sent. Now, once this request is made, it then caches it in the ARP cache so that, next time a packet is being sent to same host, ARP will not make the request again. Now, let's take a quick look at example of an ARP cache on my network. Open the Start menu, search for PowerShell or Command Prompt. Select it to open. Type ARP-A and press Enter. As you can see, this is the ARP cache on my network. I will explain this further in later videos. Now, the work of the ICMP is that, should in case this host can't reach this host on the network, an ICMP will send a message telling this host that the destination host cannot be reached, or the request is timed out. Let's take a quick look at how ICMP work. Again, open the Command Prompt or PowerShell. Type ping followed by the IP address of the destination host, and press Enter. This is a sample of ICMP message. We will learn more about this as we progress. Now, let's go to the third layer, which is the transport layer. The transport layer is also termed as host-to-host. It creates reliable end-to-end communication and ensures error-free delivery of packets with TCP. This layer employs the work of TCP or UDP. Now, with TCP, a three-way handshake occurs. With this, a reliable data connection between two devices is ensured. In this example, if this client intends to communicate with this server using TCP, the client will send synchronization request, asking the server if a connection could be established. This server will then respond by sending synchronization acknowledgement message back to this client. Then, the client will now send an acknowledgement message back to the server. When this happens, a reliable connection is then established, and data is sent correctly. UDP stands for User Datagram Protocol. With this, there is no handshake, therefore it is not secure. When I say it is not secure, I mean there is no guarantee that the packet sent will reach its destination. This is because with UDP, there is no three-way handshake, hence, does not check if data sent is intact or not. We shall compare both TCP and UDP in more detail in later lessons. The fourth layer is called the application layer. This layer is the group of applications that require network communication. This is what the user usually interacts with, such as email and messaging. It involves protocols such as Hypertext Transfer Protocol, File Transfer Protocol, Dynamic Host Configuration Protocols, etc. These protocols would be covered in details as we progress in this course. So, this how important TCP/IP is. Now, comparing TCP/IP model to the OSI model. We can see that the TCP/IP model combines some functions of the OSI models into one, and simplifies it as shown in this illustration. The main difference between the TCP/IP and the OSI model is that the OSI model is a conceptual model that is not practically used for communication. Instead, it defines how applications can communicate over a network. The TCP/IP, on the other hand, is widely used practically to establish links and network communications. The TCP/IP protocols set out standards on which the Internet was created, while the OSI model provides guidelines on how communication has to be done. Therefore, TCP/IP is a more practical model. I believe you have understood the operations of the TCP/IP. Kindly share this video and subscribe to this channel if you find it helpful. See you in the next lesson.